All right, everybody, I'm going to start by looking at completing the square. And if you are joining later and watching the recorded video, feel free to fast forward through this part because I'm just gonna type a little message. Maybe not, I don't know. Oh, doesn't want to find Penelope. That's weird. Okay, well, I'm gonna tag a couple of you. Okay, well, let's go take a look. All right. So we are going to start by looking at completing the square here. The other part of this is already uploaded on YouTube. So when we are completing the square, the first thing is we need to go ahead and move this to the other side, okay, so that we have some space there. So we're going to say 9x squared plus 24x equals 9, and I'm going to leave my space here. Now I want to factor this out because I don't want to have a coefficient of x. It doesn't neatly factor out of this, so we're going to have some messy fractions, but we're going to be okay. So we have x squared plus 24 over 9x, and then equals 9. And I need to complete the square by taking half of this and squaring it. If we take half of this and we square it, then we are going to be looking at 24 over 9 divided by 2 is the same as times 1/2. So this is also the same as 24 over 18. Now we can reduce 24 over 18 to a much nicer number. If we divide by 6, we get 4 over 3. And then if I square that to make it a perfect square, I get 16 over 9. So I'm going to add 16 over 9 to both sides. Now, when I add 16 over 9 here, I'm actually adding 16 over 9 times 9, which is just 16. So I'm going to add 16 to the other side. Now I can rewrite this as a perfect square. And 25 is a nice perfect square. Now, if I wanted to solve for x, then I would divide both sides by 9. And we would get x plus 4/3 squared equals 25 over 9. I think perhaps someone has joined me. Hey, Penelope. Are you there? If my messages are going through or not. I don't know if you can hear me or not, but I'm going to keep going. All right, so we have, then if I divide both sides by 9, I will get x plus 4 over 3 all squared equals 25 over 9. And then I can take the square root of both sides. And that's nice because 25 over 9 is a perfect square. We'll get 5/3 plus or minus 5/3. And then you can subtract 4/3 from both sides. All right, let's take a look at this one here. Penelope, if you're with me, feel free to unmute and say something or type something in the chat. But I think also my chat's being really weird. So if you've typed something and I can't see it, just text me. Okay. Oh, there you are. Okay, now I'm going to keep going. All right, so with this next problem, this is an example of a cape released problem. And so in this case, we would need to move this 5 to the other side because we want to put this in vertex form. So I'm going to do my work over here and rewrite this as negative 2x squared plus 4x equals negative 5. And I want to complete the square here, but first I need to factor out negative 2. So I'm going to factor out negative 2, and I'm left with x squared. To get a positive 4x, I need to multiply by negative 2x, and again equals negative 5. So now I'm going to complete the square by adding something in here. So I'm taking half of my middle term, so negative 2 divided by 2, which is 1, and then adding that squared. So negative 2 divided by 2 is negative 1. Negative 1 squared is simply 1, so I'm adding 1. However, on this side, I'm actually adding 1 inside the parentheses, but when I multiply by negative 2, I'm actually adding negative 2 to it. So I need to add negative 2 to both sides. So now I can rewrite this as negative 2 times x squared minus 2x plus 1 equals negative 7. This is now a perfect square, so I can rewrite this as x minus 1 squared. And then I want to put this negative 7 back on the other side so that it is in vertex form. So I'm going to add that 7 back to the other side. So now this is in vertex form. So I can complete what's here by making this a minus 1 and a plus 7, which means that my vertex will be 1, 7, because this is the same as negative 2 times x minus 1 squared plus 7, which means that my vertex is 1, 7. If you have any questions, feel free to let me know. All right. The next piece is looking at the quadratic formula, and so you're lining up A, B, and C using this formula. This formula will be on your CAPE reference sheet, so you don't need to memorize it. You simply need to plug in, decide A equals 9, B equals 24, and C equals negative 9. The key thing there is that you have to be careful with your negative signs. And then you plug those into the equation. So we're going to plug in negative 24 plus or minus the square root of b squared would be 24 squared minus 4 times 9 times negative 9 all over 2 times 9. This kind of quadratic is a good equation to use the quadratic formula with because the numbers are so much larger and we have a coefficient here. And so then you can go ahead and you can use your calculator to calculate negative 24 plus or minus the square root of 24 squared. I'm going to use a calculator for that because I don't have 24 squared memorized. So 24 times 24 is 576. And then 4 times 9 is 36. That's a negative 36 times a negative 9. So we're going to get a positive answer, and it's going to be plus 324 divided by 18. So 324 plus 576 is 900. So you'll get negative 24 plus or minus the square root of 900 all over 18. And then we can go ahead and take the square root of 900, which you might recognize is 30. So this is going to be, I'm trying to find space here, negative 24 plus or minus 30 all over 18. And so we'll get negative 24 plus 30 is going to be 6 over 18, or 1/3. And negative 24 minus 30 will be negative 54 over 18. And you can reduce that to negative 3. LB, let me know if you have any questions. All right, axis of symmetry. So there's two ways we can find the axis of symmetry and find the vertex. And the first way is if we have our x-intercepts, we can find the midpoint between them. So here our x-intercepts would be 3 and negative 7. So we're looking for the midpoint between those. So I'm going to add 3 plus negative 7, which will give me negative 4, and divide by 2, which gives me negative 2. So my symmetry will be on x equals -2. And then if I wanted to find y, I plug in -2 to this equation to see what I get for y. So I get -2 minus 5 times -2 plus 7, which will give me -7 times 5, which is -35. So -2 comma -35. Our vertex is going to be all the way down there somewhere. Okay, so again, finding the vertex, if we have the x-intercepts, we find the midpoint between those two, and then plug in that value for x to find out what y is. You can also use this formula if you have it in standard form. So using here, if the standard form, you can plug in b, -b divided by 2a, and that part of the quadratic formula will tell us what the axis of symmetry is. All right, for this equation, let's first find our x-intercepts. So 2x minus 6 equals 0, 2x equals 6, x equals 3. That's one of them. And the other one would be x plus 9 equals 0, so x equals -9. Add those together and divide by 2. So 3 plus -9 divided by 2 is going to give me -6 divided by 2 is -3. That's my x value, so that's our axis of symmetry there. And then I'm going to plug in -3 to find the y value. So 2 times -3 minus 6 is going to be -6 minus 6 is -12 times -3 plus 9 is 6, so that'll be -72. So -3 comma -72 is our vertex. All right, writing equations with the vertex and the y-intercept. So if we have this information, can we write an equation? So if the vertex is 3, 2 and the y-intercept is 0, 10, write an equation for the graph. So f of x equals a is what we don't know times x minus 3 squared plus 2. What I don't know is a, so I'm going to use this point to find out what a is. So I'm going to plug in 10 for y equals a times and 0 for x. 0 minus 3 is -3. -3 squared is 9 plus 2. Okay. And so then I can go ahead and solve this. I'm going to subtract 2 from both sides. I'll get 8 equals 9a. That means a equals 8 over 9. And so now my equation then is going to be f of x equals 8 over 9 times x minus 3 squared plus 2. All right, writing an equation from the graph. So here, if we have the graph, we can use the vertex, we can use another point, we can use the x-intercepts and the y-intercept to help us write an equation. So in this example, it says a parabola with this equation has a minimum, so that's the vertex, at the point 2, -1, and a y-intercept of 3, so 0, 3, when graphed in the xy coordinate plane. So it asks what are the values of a, b, and c. Select the 3 that apply. So we know that if 2, -1 is the vertex, then the point that it's going to be in here is y equals a times x minus 2 squared minus 1. And remember that this is the opposite of what we think it is for that sign there, because that negative is part of the equation. So that means b is going to equal 2, and c is going to equal -1. We know that much. The question that we have then that we need to figure out is what does a equal again? So we're going to take this point and plug it in. So 3 equals a times 0 minus 2 is -2. -2 squared is 4 minus 1. If I add 1 to both sides, I will get a equals 1 then. So a equals 1. So my new equation now is y equals 1, which I could just leave, x minus 2 squared minus 1. And then it says, what are the x-intercepts of the parabola? So now I need to take this equation and put it into standard form and factor it. So I'm going to put it into standard form. I will get x squared. So let me do x minus 2 times x minus 2, right? And then minus 1. So I'm going to x squared minus 4x plus 4 minus 1. So x squared minus 4x plus 3 is my equation. And now I need to find my x-intercepts. I'm going to do that by factoring. So the number that multiplies to give me 3 and adds to give me -4 would be -3 and -1. That means my x-intercepts are 3 and 1. And once you've gotten to this point, you can also always plug this into your graph or into your calculator and see what you get for those x-intercepts. All right, this part here is going over the discriminant. So remember, we have our equation -b plus or minus the square root of b squared minus 4ac over 2a is our quadratic function, right? Our quadratic equation. The part underneath the radical sign is the discriminant, and the discriminant helps us to see how many solutions there are. This front part of the equation is what we use to find our axis of symmetry. So both parts of those are important, and this formula is on your reference sheet. So when you get your reference sheet for the test, strongly encourage you, go ahead, write on your scratch paper, mark it up so that you remember these things as you're testing. So it says determine how many solutions each equation has. So what I'm going to do is take parts of my equation here and plug them in. So this is 6 is A, B is 10, and C equals -1. And I'm going to plug that in, and so I'm going to get 10 squared, B is 10, so 10 squared minus 4 times A times -1. So the square root of 100, a -4 times a +6 is -24, but -24 times a -1 is +24. So we have a positive answer here, so there will be 2 real solutions. And it will be the square root of 124, so they will be real, but they will be irrational. All right, so try the same thing with these and figure out if it will be 1 solution, no solutions, or 2 solutions. I'm going to pause myself and mute myself real quick because I need to get my son out the door for soccer practice. Oh, you typed hi. Hi, Penelope. Okay, give me a second. I'm going to pause for just a minute. Penelope, do you have any questions? Really, my chat, I don't know what's going on with that. Sorry. Okay. All right, so let's go back and take a look at this part right here. A is 3, B is 3, C is 48. So the square root of B squared, which is 9, minus 4 times A times C. So times 3 times 48. You should immediately recognize that this is going to be 9 minus a very large negative number, right? Or minus a very large number, which means that this is going to be the square root of a negative number, which means that this is going to be no real solutions. All right, let's look at the next one. So negative 17 squared minus 4 times 3. Okay, so here as well, or here, not as well, rather, you're going to get 17 squared is 289. So square root of 289 minus 16 times 3 minus 48. So we'll get a positive number inside this bracket. 289 minus 48 is going to be 241. And so you will also have 2 real solutions here. Okay. All right. This last part of this is a word problem, and it's just using quadratics, right? So remember, quadratics we often see with gravity, where we have negative 16 when it's feet and negative 4.9 if we're looking at meters per second. X always represents the time, and then f of x or y is the height. So this is an example of an arch in a wall in which we have the distance from the wall from the left end of the wall. So this is like our axis right here. That's our y-axis there. This is our x-axis here. So I'm going to draw a little, that helps me. So it says, what is the factored form of the function? So notice they have in parentheses a number before that, and all of these numbers are divisible by 2. So I'm going to start by factoring out that negative 2, and I'll be left with d squared minus 6d plus 5. Okay, so negative 2 is going to go into the first box. Then I need to factor what's inside the parentheses. So I'll have d and d. To get a positive 5, I'm going to do negative 5 times negative 1, because negative 5d and negative d will be negative 6d, but negative 5 times negative 1 gives us that positive. So d minus 1 times d minus 5. Says select the phrases to complete the sentence. The largest value of d for which h is 0 is, so which value can I put in for d that will give us a height of 0, meaning which of these points here will give us a height value of 0. And so you're looking at 5 there. Someone else join me, or Penelope, did you just unmute? You have a question? No? Okay. Feel free to text me if you need to, if I'm going too fast, you need me to slow down. All right, so the largest value of d for which h is 0 would be 5, because we would do 5 minus 5 would give us 0. That's our largest distance from the end of the wall here. And it says this value is the, so not the height of point B, not the distance from point A to point C. So it's not the distance here. It's the distance from the left end of the wall to point C. So it's that distance there. So it would be this answer right here. Okay, because if we're looking at this as the axis and then these points are here. Right, this is the x-intercepts, and then this x-intercept here measures the distance from this wall to that point. All right, here is another example question of a projectile situation. Mine is a little, okay, there we go. All right. And so the projectile shot in the air, the altitude of the projectile after t seconds is modeled by this function. Time is in seconds and altitude is measured in height. So it says, which of these statements is true? The projectile reaches a maximum altitude of 12 feet. Well, the maximum altitude here is at 12 seconds and 19.4 feet, so that's not true. The projectile reaches its maximum altitude after 12 seconds of flight. That is true. The projectile is launched from the ground. No, because its starting value is 5. And the altitude of the projectile is increasing on the interval from 5 to 20. So from 5 to 20, it does increase, but then it goes back down. So that is not true entirely. Part B says the table models the flight of the projectile from part A. Which of these statements is true? So this is the table here. And is it h of 4 is less than h of 20? Well, h of 4 is 13 and h of 20 is 13, so they're the same. The flight is symmetric about the line t equals 10. So if we look up here where t equals 10 is a little bit to the left of the axis of symmetry. And then C, the projectile. Ooh, hold on just a second. I think my son's getting picked up. Okay, sorry, he's off to soccer practice. Where were we? Okay, C, the projectile will hit the ground at some value of t less than 24. No, it is still in the air at 24. We can see that it's still at a height of 5 at 24 seconds. So it'll be after 24 seconds. And it says if A is between 0 and 12, so that's between here, then h of 12 minus a equals h of 12 plus a. That seems like a really weird way to say this, but what it's saying is that on either side of 12, which is where our axis of symmetry is, we'll get the same output. So D is the correct answer here, because if we were, for example, to say 5, and we do make A 5 and we say, actually, if we were to say, let's make A 8, and I say 12 minus 8, that gives me h of 4, right? So h of 4 is 13. And then if I do 12 plus 8, that's h of 20. And h of 20 is also going to be 13. And so what this is basically saying is that on either side of the axis of symmetry of 12, the heights will be equal because it's symmetrical. Okay, all right. The attached questions, so what I would say to do is to make sure you read through this information and that you know the statistical words and information. You don't really need to memorize any of these formulas or equations. You just need to know that when we look at the mean absolute deviation, when we look at absolute deviation, it helps us to tell how varied our data is. The bigger that number is, the more varied it's going to be. All right. Oh. Welcome back, I think. Okay. And so when we're looking at that standard deviation, we're just making sure that that information is telling us how much our data is away from the mean, right? So how big of a difference we have from the mean. So the questions that you have here, the first like 4 are multiple choice, and it's just you analyzing and looking at these graphs. Most of your data and statistics questions are going to be just like logic, right? So just reading and carefully using your brain and thinking. A lot of them are reading comprehension. If you read it carefully, you'll be able to get it. So for this part here, I mostly want you to focus on the multiple choice questions. You can actually skip the Bella tomato questions because we did those earlier. But I'm not going to go through all of them. If you have questions about them, though, you can definitely text me and ask me. All right, Penelope, if you have any questions now, you can feel free to ask me too. Or nope, you're gone again. Okay. All right. Well, that's it. I'm going to stop here and then I will make sure that you have access to this video. Bye.